Today is the day. We're going to GigaStack the retro rack. We're going to be looking at the Cisco 3500 and 3550 series switches from the late 1990s and early 2000s, which can accept a very interesting module Cisco offered, a GigaStack module. The GigaStack module lets you interconnect this gear over a 1 gig link and manage the switches as a cluster in the Cisco Cluster Management Suite. You can see all the units in your cluster in pixel art form and administer them in a central location. We'll get some more gear racked up and do some cable management, have a little Cisco iOS 101 tutorial, mess around with some fiber connections, and configure all this stuff as a GigaStack cluster. Let's get into it. This is a pile of Cisco 3550 and 3500 series networking switches from the early 2000s. I think most of these particular units on the bench here were manufactured in 2003. The 24 ports on the left of each machine are 100 megabit, also referred to as fast Ethernet, but these were built when 1 gigabit links were quickly making their way into serious data centers around the world. To support that transition, these units each have 2 GBIC ports, or gigabit interface converter ports, but I think folks always just pronounce it as GBIC. These ports are modular, meaning that different types of GBIC modules can be inserted into them. For example, we've got this 1 gigabit module here, and it's got the familiar RJ45 form factor coming off the back, which of course we're all familiar with. So now you've got a 1 gig port here over RJ45, and here's a 1 gig fiber module, fiber cabling being very common in data closets and data centers. And no surprise, you can plug your fiber cable in there, and now you've got 1 gig going over fiber, 1 gig going over RJ45. But these series of switches are special across the suite of products Cisco was offering at the time, in my opinion. I've even thrown a curveball. Here's a Cisco 2950 series switch. You can see they're all very similar looking. And this is because of a very unique GBIC connector Cisco produced, the GigaStack module. GigaStack modules, yes, they're literally called GigaStack modules, are these interesting little guys right here, and they've got 2 ports coming out the end, and that's obviously the physical form factor of a FireWire cable. Let's get one in here. Now that looks like a FireWire port. It's the same physical connector, but I think Cisco was doing something funny, like they crossed some of the pairs or something. So you do have to buy the official Cisco branded GigaStack cables and plug them in just like that. So I don't believe you can use just any old FireWire cable in these things, and this cable in turn can't be used in other actual FireWire gear. But why would they do this? Well, you can actually stack these things and cluster them together once you get them interconnected with the GigaStack modules, and run something called the Cisco Cluster Management Suite. The software allows you to administer and configure the stack of switches all in one place, and it even has an incredible looking Java app to let you administer the stack visually. Now, I keep calling this a stack, and Cisco even called the modules GigaStack, but it's not a true stack, it's a cluster. So you're actually just taking all the switches and making it so you could administer them conveniently in one spot in that app. In the app, you're configuring each switch separately. Now, a true stack, which this hardware can't do, you can think of it as actually combining them all into one switch, and they can share load. You would refer to that as like backplane throughput. They could share a backplane, so if one's under load, they can kind of spread it out amongst each other. These don't work that way, so if one of these is like totally bogged down, it can't spread compute and throughput capabilities to the rest of the cluster. That would require gear that can do some true stacking, which Cisco did have some of that stuff. But the GigaStack stuff is still pretty sweet. In a past video, I was able to actually get it working here on the bench with a few units, but I haven't GigaStacked the retro rack. In the other room, I'm building out what I'm calling my retro rack, full of late 90s to mid 2000s networking and enterprise server gear. My main switch is another of these Cisco 3500 series guys, but that one can actually deliver inline power, meaning we'll be using it to power Cisco IP phones in the future. Putting that gear in the rack was no mistake. The plan all along has been to put even more of it in the rack and GigaStack it up so I can administer it with that awesome UI, which makes like pixel art versions of all the switches. It's excellent. So the plan today is to rack up yet another of these 24-port 3550 series switches, and we'll use that very large one in there with all the GBIC ports on it as something called an aggregation switch. But what's an aggregation switch? Well, I've got a slightly smaller one here, of course. It's got 8 GBIC ports across the top. These are all 1 gig ports. And with an aggregation switch, you wouldn't necessarily plug a computer into it directly, though of course you could. You would aggregate all of your equipment into this switch. For example, these would be connected up like that. all of your gear is connected through one central aggregation switch with probably a higher throughput or a better backplane, and it in turn would be connected to your router and the rest of your network or whatever. You could imagine an aggregation switch might be in like a larger network closet, and all the switches on maybe multiple floors of your building link back down to the aggregation switch so that they're all on the same network. I actually have a more modern version of this in my rack. I've got a Ubiquiti egg switch in there. That one's doing 10 gigabit speeds though. And you can see right there, those SFP plus modules, that is the form factor that superseded these GBICs. I'm trying to take everything out and wow, this is terrible. Imagine if you were like cramped in there, wires going everywhere. Really hard to get those out once they're next to each other. Should make a quick note. You'll notice some of my gear says 3500 series XL and some of it says Catalyst 3550 series. This XL stuff came out earlier, I think like late 90s, and it's actually less capable than the 3550 stuff. These can do like layer 3 switching. I think these can do a little bit of that depending on, the version of the software you're running on them and everything. We'll try to stick mostly with the 3550 series stuff. But it also doesn't really matter because I'm not doing any layer 3 stuff. And the naming on this Cisco gear can be kind of confusing. Here's that Catalyst 2950 series switch I was briefly showing you earlier. It is actually newer and probably more capable than the Catalyst 3500 series XL. And the best in this whole stack here is the 3550 series. I guess all you got to remember when you're talking about this range of switch, the 3550 series are the best ones, or most capable, I should say. Don't be confused by the XL, because this 3500 series XL actually came out in the late 90s, whereas this Catalyst 2950 series, I'm guessing, was sort of to replace this line in the early 2000s, so it's kind of confusing. I guess if I was to stack these by age and capability, it'd be something like this actually. Least capable to most capable. So there you go. So we've got a lot of racking and configuration ahead of us. We're going to put a patch panel right under the stack we've got in there today. We'll put a 3550 series switch right under that. Bought a bunch of patch cables. We'll try to get everything interconnected as nicely and cleanly as I can. We'll see how that goes. Oh, and then of course we'll GigaStack. But just to give you a little taste of this GigaStack stuff, I think this guy is running the Cluster Management Suite. Let's power it on real quick and have a look, and then we'll get to work. I was wrong. It was actually the switch in the middle of the stack that is hosting the software. Do not worry, I'm going to cover in way more detail than you or I will ever want how these things get CMS installed on them, how they host it and everything once we start GigaStack and everything. But here I've hit the IP of that switch in a browser, and you can see it's popping up with something called Cisco Device Manager. And I think we can go continue and hopefully get into the real deal here. All right, this is not CMS, but you kind of get the idea. I mean, here's our switch. We can interact with it. You can actually like virtually press the button on the front, which is like way more fun than it ought to be. When these things aren't clustered up, which we will do later, don't worry, they're hosting something called the Device Manager. So you can actually get into this visual UI of the device, see if the fan's okay, see what it's up to. Still really cool in its own right, but we're gonna take it one step further and get stacking. The very first thing we're gonna do is get a patch panel right here. Now there are tons of ways to do cable management, and there's an argument, a pretty strong argument to be made, that I should just be racking the stuff on the back of the rack. You can mount stuff, the opposite direction, and then all the computers would just flow into there. But I'm gonna do this because I think it's gonna end up looking really cool. The plan is this patch panel will service at least this guy. I did something very similar in my other rack, and I really like how it turned out. And I'm gonna try to recreate that here. I think it's gonna end up looking pretty good. So I'll zip this guy in. That was easy. Like I was saying, there's lots of ways we could route this cabling. We could get trays, we could do it on the side. We're gonna do it this way, at least for now. It's kind of like Legos, the home lab. I'm gonna rebuild all this. A year from now, this is gonna look totally different. What you definitely don't wanna do is get in a situation where you've got cables crossing multiple units. And so imagine if I had just slapped my switch in here and I had cables crossing down and over. That gets you in a situation where it's really hard if I need to replace this. I gotta unplug a bunch of other stuff that has nothing to do with what I'm trying to accomplish, and it becomes very arduous. This is the main uplink to this router, and so this guy actually isn't even powered on. We haven't configured this, we'll do that together, but basically it has a 1 gig link now to the egg switch. All this stuff, there's various computers and everything. These yellow cables from Monoprice are a joke. The boot stops you from pushing the thing all the way. Anyway, they suck. Don't buy them. These ones are way better. So we'll get all this out. And now what happens is I'm just gonna push that through the back. And so these first 6 will be these cables. And then let me show you the patch cable situation. The way these ports are numbered, it's 1, 2, 3, 4, 5, 6, and so on, which means you're gonna get an awkward situation as you're cabling into 1, 2, 3, and you can imagine this one has to go way over here in the patch panel off screen. So I bought these thin ones on Amazon. They end up being quite a bit thinner than a traditional Ethernet cable, and the idea is it helps you route easier, and in a tight situation like this, it's going to be a little less painful. We'll see if I regret this once we're done and see how it looks. I'm going for a certain aesthetic here, obviously, and I don't think people were using these thin ones 20 plus years ago, but if that's not true, let me know. These are really nice. These come out super nice. Very happy about that. Next, let's get another switch in here. So this one actually delivers inline power, and my thinking here is I don't necessarily need to be doing that for everything. Like maybe I don't want this on sometimes. So we're gonna rack another one in here. I think we have room for another patch panel. If I want to do that, we might share this patch panel for a while. I'll plug these in on the back and go get that other switch. Trying to get my rack ears on here and I'm seeing a problem. I would like that to be like there. These are not the right ears. I'll be right back. Bad news, I don't have the right ears. So this is just gonna have to look stupid for a while until I hunt down the right set. Would it have killed the industry to come up with like a standard? Every piece of equipment in this rack is different. There's no way we're just GigaStacking 2 things though. We need a third in here. That'd be lame. I'm actually pretty sad this rack is filling up and I'm running out of these nice workbenches. Pretty soon it's just gonna be full. Bunch of folks, see, dumb. Oh well. Bunch of folks made the pretty reasonable observation that when I'm racking this stuff up, I should start with the bottom screws. Come on, buddy. Because then, you know, the laws of physics sort of hold it in there and then you can deal with the top ones. See, like I have 1 screw in. This rack hardware is super strong. Obviously you shouldn't leave it like this, but I think you get my point. Man, that looks so stupid. Oh, that's frustrating. Oh well, but it's in. So now what we're gonna do is see how long we can get away with these 6-inch patch cables. I bought 1-footers as well because I just don't think it's gonna work without them. But as you can see, I think it's gonna look pretty cool. They get kind of bunched up the closer you are to the port, of course. But yeah, I've never used these small ones before. Man, that makes it super easy. Yeah, it looks like at port 18, I'm gonna have to switch to these longer ones, and then of course it's gonna look kind of stupid. Not that I'm too worried about it. So yeah, it's just gonna stick out more, unfortunately. But I think that's okay. I could, of course, you know, make my own, but that doesn't sound like a very fun project, so I probably will not do that. It's looking okay. And there we go. The retro rack's growing up. We got an official patch panel. All the machines I want to plug in obviously can come off the back of the patch panel. No more wrapping around like this one is. That looks pretty slick. I'm actually pretty happy with that. I'm glad I went with yellow because these have these yellow accents. I thought that would look cool, and indeed it does. Now, we need to get these all hooked up in a way that we can configure them, and then we need to start configuring them, and that's going to be a lot of command line iOS action. The software that runs on these Cisco units is called iOS, and I think it would be beneficial, before we get real deep into it, to have a little iOS 101 lesson. Sit back and enjoy. By the end of this short tutorial, you will be able to access and configure a piece of Cisco networking equipment, a router or a switch, configure one of its interfaces to get it on a network of your choice, and you'll be a little more familiar with iOS. Cisco devices run software called the Cisco Internetworking Operating System, or iOS for short, Today we're going to be configuring the Cisco 2600 series router. This Cisco 2610 came out in 1998, so it's a little on the older side, but iOS has maintained a certain consistency over the years, and I think the newest piece of Cisco equipment I have is from 2011, so I can't really prove this, but I suspect everything we're going to do today is going to look really familiar in a modern Cisco device running iOS. On the back of Cisco equipment, there is going to be network interfaces and power and everything, but there will also be something labeled console, a console port. You will need a console cable, which takes the RJ45 form factor there and converts it over to DB9 serial. If your computer already has one of these serial ports, you're good to go, but it probably doesn't. So I use this DB9 to USB serial adapter. I've had really good luck with this thing. It's worked on almost anything I've ever tried. I'll link to an Amazon link down in the description. They also make versions of these cables that are just USB. You're not dealing with that at all. I don't happen to have one of those, and I plug in other serial devices all the time. So this is the setup I'm going to use to get our console port plugged into my modern computer with USB. Now, one way to think about this is that this thing is a computer itself, and you're using the console port to be able to plug in a keyboard and monitor. That's essentially what's happening here. We're going to get this in my other machine and use a terminal emulator. It's all text-based, CLI, command line interface-based, but basically this is letting us get a keyboard hooked up to this thing and see some text output. That's the idea. I've got this all hooked up here and ready to power on. This is all you need to do the kind of first examination of a device you've just picked up. Let's go talk about how you actually see some output on your computer from this console. You're going to need a piece of software called a terminal emulator to actually interact and connect with the device. If you're on Windows and you're starting out, I would use PuTTY. It's an absolute classic, tried and true. There's other options, but it's what I like to use when I'm on Windows. If you're using Linux, I really like Minicom. There's other options as well. It'll be a little more advanced if you're starting out, but plenty of tutorials online how to configure a terminal emulator. The important part for this Cisco unit is in PuTTY. If we go down to the serial section, any terminal emulator you have will have a way to configure what I'm about to explain. So the speed of the link, 9600 is very typical, and it's what almost all Cisco stuff uses. 8 data bits, 1 stop bit, no parity, flow control off. What you're seeing here is like the basic serial setup. Cisco routers and switches and gear are very forgiving. I've found them to be really nice to interact with over the serial console. These, in fact, are probably the defaults in PuTTY and the defaults for a lot of other gear. One last oddity if you're on Windows. Windows uses something called a COM port to expose a serial port, and you can see I've opened up Device Manager here, and we've got ports, COM, and LPT. And if I pull this down, my one USB serial converter is plugged in, and it has been assigned COM5. We need to know that back in PuTTY, so you can see I have COM5 plugged in right here. And then if we go back up to session, we're going to connect to COM5 at 9600 baud, and we do open. And finally now, we have a terminal window. Let's power the router up, and we should see some activity flowing across the terminal. Booting up, we can see it's saying System Bootstrap. So this is what I meant by the console port lets you plug in a keyboard and your monitor, basically. So now we can actually interact with this thing. This old boy is going to take a few minutes to boot up, and I'll be back. When it's up, it'll finally say press return to get started. Don't be alarmed if that takes a while. Sometimes they take a while to boot up. And if we press return, and I'm going to press it a few more times, we're at this prompt. Router happens to be the name of the router. The Cisco default is router. If it's a switch right from the factory, it's called switch. Pretty reasonable. This level of CLI we're at here is called user exec mode. At any time, you can press question mark, and it will spit out all the options available to you. You can't do a whole ton at this first exec prompt. So one useful thing, I guess, is ping. So we could, ping some address. We're not on a network, so ping's not going to work. And then show. Show is a really important command to get the router to tell you stuff about its configuration. And again, I can use this question mark after a command if I don't know enough about it. So, well, let's be really thorough here. Ping question mark, and it'll tell me all the stuff I can do with ping. And then again, we'll do show question mark. I can show stuff about all this, but most of the time you're going to want to get into what's called privileged exec mode. And you do that by typing enable. Another thing about the CLI is you can shorten the commands. You'll hardly ever see someone type enable to get into privilege mode. They're almost always going to type N because it's literally less work and you can move around the command line faster. So I'm going to type N, and now you can see our prompt has changed. It's a £. This is privileged mode, meaning we can do more stuff. And again, if at any point I want to see what I can do, I can press the question mark. We've got more show stuff we can look at here. And if you'd like to move between the prompt, you can think of it like a hierarchy. So I can type exit, and I'm back into user exec. Of course, go back in. Now, those are the very basics of getting in and out of the router, and now we can interact with it. And we know what privileged mode is. We're going to use this basically for the rest of the configuration steps. Let's learn how to configure an Ethernet interface. This router is quite simple. It only came factory with one 10 megabit Ethernet interface. And notice that it is labeled Ethernet 0/0. That is a unique identifier for this port physically on the machine, and that's how we tell the configuration what state we want this thing in. This router has other modularity, so we can put some cards here, here, and a bigger one here. Obviously, I don't have those populated. They'll also have unique identifiers, and this one can hold multiple interfaces. Here's a card with 2 fast Ethernet ports on it. This is a bad example because this card is not compatible with this router, but I think you'll get the idea. These are also going to have unique identifiers. This is labeled fast Ethernet 0, fast Ethernet 1. So if this is slot 1, and this card is in slot 1, the identifier for fast Ethernet 1 would be fast Ethernet 1/1. And over here, fast Ethernet 1/0. The 0 port on card number 1. But I might be getting a little too far ahead there. This has one Ethernet 0/0. Let's go configure that one. Back at the terminal, let's get into privilege mode. And I'd like to show you one more little quality of life thing I was glazing over and doing out of habit. So let's do that help command again. And you can see at the bottom it says more. When I press enter, it advances the screen and it's telling me, yeah, there's still more. And eventually, if I keep holding this, we will, run out of options and we'll be back at our command prompt. Let's get back in there. Of course, we have more. If you press Q, you can exit out of that and you're back to the prompt. I'm doing that just out of habit and not even discussing it here. Let's do another useful show command from privilege mode. We can do show interfaces. And it's going to spit out a ton of information about each interface. We only have one, but you can see it is called Ethernet 0/0. So this is a definitive way to find the unique identifier for the interface you're concerned with. Now, to actually configure an interface, there is, of course, the configure command. And as I'm typing, I'm tabbing to get autocomplete. And let's do our help again. We want configure from the terminal. We are at the terminal. All the tutorials you see online are going to be configuring from terminal. And they're almost always going to say conf t, which is just short for configure from terminal. And you can see our prompt has changed slightly. We're in this config mode. To configure an interface, you do interface. The interface name, ours is Ethernet. I'm just tabbing to let it autocomplete 0/0. The prompt has changed again. We're in config-if, config-interface. The prompt is just letting you know that you've kind of traversed in and you're targeting a particular piece of the router that you're configuring. The basic thing we want to do here is add an IP address. I've got a rack running in the other room. It's got a 10.0.0 network. We're going to give this thing an IP on that network and see if we can ping the big router in there. The command to do this on the Ethernet interface is IP address. You will almost always see someone say IP add. So it kind of makes sense if it was the word add, but it's just short for address. We'll give this, 15, and then you do need to give it a subnet mask. This is not a subnet IP CIDR tutorial. You'll have to trust me that this is the correct command for my situation anyway. And there we go. Not very exciting. But when you configure something on a Cisco device, it is immediately effective. Whatever you have just configured is live on the router. So let's exit back to exec mode, and I'll show you, and you can see it's saying that it got configured by the console. We'll talk about these console messages a little later in the tutorial. I'll show you something else as well. So let's go back and configure that interface in Ethernet 0/0. Now I'm pretty deep in the hierarchy. I'm configuring a specific interface. If I just want to get back to exec mode, I can type end. So instead of this exit thing, the double exit thing I did before, you type end, and now we're back in exec mode. The next thing you absolutely have to know is show IP interface brief. And here we are. We have configured Ethernet 00. It is at 10.00.15, just like we told it. And I gotta change my console window here. Now you can just barely see it. The protocol is down. This just means either something's wrong with the wire, or in our case, the wire is not plugged in. You're almost always going to see me and other people type this as show IP int brief. The brief version, I guess, because it's just less to type. It's way better than typing out the word interface. Now you use brief because if we just do show IP int, it's going to give us a ton of information about that interface, which is usually only useful in pretty deep troubleshooting situations. So the brief command is the way to go. The other end of this cable is going into a switch on that 10.00 network I was just showing you. And if we plug this in, we can see a link light has come to life. And we've got a little bit of an activity indicator action going on over there. Back at the console, you can see we got a message about the state going to up. Let's do a show IP int brief again, and there it is. Now the status is up, protocol is up, meaning the link is online, which should mean we can use our ping command. Let's try pinging the router in the other room. And we're in. So this thing is attached to another network. We've configured its interface with an IP. Now we need to learn how to actually persist these changes we've made. But we're not done yet. Let's address one quality of life thing, and then I'll talk about how to actually save this config. So these automated messages show up by default as things change about the interfaces. So for example, let's go into CompT and look at our interface. You can shut down administratively or bring up interfaces. So I'm going to put this into shutdown. That's how you actually turn the interface off with the CLI, no matter what's plugged into it. And then if we end, and if I kind of like start typing, you can see all this stuff is coming down. It's telling us it's down from, administratively down from the console. The line protocol just went down. And it's very frustrating while you're typing commands. There's a handful of ways to deal with this. I usually just turn off all the logging. So you can do no logging console, and that'll just shut those messages up entirely. But there's a way to actually get the messages and not let them interrupt your typing. I'll show you that one now. We're actually going to configure the serial line. So just like we configured an interface, we can also configure the serial port, and it happens to be line 0. This is a little advanced, but we can do logging synchronous. And what that's going to do is make it so that my actual typing doesn't get interrupted by those messages. Let's see if I can show you here. Let's configure our interface yet again. You will get very good at this. And now remember, I have it shut down. The opposite of shutdown is no shutdown. In Cisco parlance, you almost always invert a command with no in front of it. So we're going to do no shut. Again, hardly anyone types shutdown. I'm going to end right away, and I'm going to do a show IP int brief. And you can see these messages are coming in. Hopefully this is making sense. But my command is staying intact. It's continually pushing my console line down instead of letting it end up in the middle of these messages, and then you get really confused. Let's talk about configuration. Every Cisco unit has two configurations inside of it, the running config and the startup config. When it boots up, it loads up the startup config file, and then as I'm interacting with this, I'm changing the running config. So if we do show running config, we're going to see our changes. Here's me with my IP address and all that. Again, Q to get out of that. We can also do show startup config. And if we come down here, my interface has not been configured. So what's going to happen if we reboot this router? Everything we've done is going to go away, which is useful in some cases. When you totally hose everything, you can just reboot the thing, but not what we want here. The old school way is you would copy the running config to the startup config. I hardly ever do that. I use the write command. And of course, WR is short for write. And it actually takes everything we've done live, that the router, the way the router is actually functioning at this moment, and puts it in the startup config. That's done. Now if we do show startup config, it has our changes. We've copied everything we've done and basically written it out to the startup config. I find it's just easier to think about it with the write command. It's almost like saving your changes rather than needing to worry necessarily that there's two different config files in play here. And I think we've done it. That's Cisco Configure and Interface iOS 101. You passed. So there we go. This guy's configured. Not a very interesting configuration, but now, with the basics under your belt, the sky's the limit. You can put modems and T1 cards and more Ethernet interfaces and all sorts of stuff. Let me know if you like that 101 class. There's more advanced topics we could cover, of course. Maybe I'll do that in future videos. I suppose it might have been more accurate to call that iOS 101 if we happen to be living in 2005. But let's get ready to make this stack happen. Start with power. So I want to go left to right, top to bottom, starting here. So power port 1 will be this, 2, 3, 4, 5. I'll get that wired up. And then this is a really critical piece of the puzzle. This is called a terminal server. If you remember that console port I was showing you with the console cable, well, this thing's got 8 of those cables coming off the back of it, and it hosts itself on my network at this network anyway, at 10.0.0.2. And so I'm going to do the same thing. This is actually plugged into itself with cable 1, 2, 3, 4, 5, and I'll document all that. I'm going to wire that up, and then we'll power everything on. I just wired up the power just like I described, top to bottom, 1, 2, 3, 4, 5. Same deal with the serial ports coming off the back for the console access. I think we just need to boot up. Let's see. This one has no lights. He's on. That one, you can't tell on camera, but the lights flicker when this big guy comes on. A lot of inrush current. That should be this. Yep. This one's on. And finally, this one. All right, let's go configure all this stuff. It's been getting to the point where I can no longer actually remember the IPs I've assigned to everything, so I'm starting to document it. The way that VXR is set up, it's a DHCP server, but I've reserved the first 100 addresses, meaning I can use those for static assignment, and I'm going to use those for the servers that are in there and the networking equipment. So basically 100 through 254 are just going to be handed out by the DHCP server. We don't need to worry about that. The router, the VXR, is .1. The term serve is .2. We're going to set up that aggregation switch as .3, that power switch as .4, and that new switch at the bottom as .5. I've started to reserve off static ranges for special machines. So all my Sun gear is going to start at .50. I've got some IBM gear at the bottom. I'll probably start that at .60 or whatever. You get the idea. And I'm also keeping track of the terminal port that it's plugged into and the machine name. The VXR is HQ router. The AG we're going to call AG1. The term serve is term serve 1. The main switch that was already in there that delivers inline power for phones and whatever else, we're going to call that power switch 1. And then the switch we slotted in the bottom is just going to be regular old switch 1. I like to add numbers at the end in case you have more things coming in. So I just as easily could have called this, switch 2 or something, and it wouldn't have been confusing. I kind of like having the power in there. I think it sounds cool. Let's go see if we can access everything over the terminal server. The way that terminal server works is I telnet to its IP, it's at .2, and then ports 2001 through 2008 give me one of the 8 cables coming off, and that's why it's important to know which port and cable is assigned to which device you care about. So this will get us into the router, hopefully, and we can see we're at HQ router. And what we're going to do is take a look at the new equipment. So port 3 was the egg switch, hopefully, and it is. We will configure that shortly. And let's take a look at 4 should be power inline. It is. And finally, let's take a look at that new switch at the bottom. This should be switch 1. It used to be called switch 2 in a different life, but yeah, that's that switch at the bottom. So we can access all of our devices over the terminal server. The typical way is I'm doing that thing where I'm telnetting and then to a specific port to go right to a device, but I set it up that if I just telnet directly, check this out, an automated menu, and I can do 1 to go right to the HQ router, and then we're in there. So what I'll do, and you can do Control-Shift-6 plus X to get back. I'm not gonna lie though, it kind of misbehaves. So I'm gonna go back to HQ router. over there, right? Control Shift 6X. Now if I try to go back to the router, it refuses the connection. It's like holding onto it and not resuming it. Anyway, I got a little work to do on this thing, but probably the coolest thing I've built in a while. I've got the host names all set up, so let's get into the AG switch and start taking a look at the IP situation. So we'll do show IP int brief, and you can see I had previously been messing around with this thing, and I've got this VLAN 1 interface assigned to this 192.168.2.12 network, which is not what we want. So let's get into compt, and we're going to configure interface VLAN 1, and let's give it the IP address from my sheet, which I've already forgotten. .3 is what we want. IP add 10.00.03. Show IP int brief again, and that is good. But what is a VLAN? VLAN stands for virtual LAN, and it lets you subdivide one physical connection into multiple virtual LANs, virtual networks. So for example, I could set up two VLANs, a 10.0 VLAN on VLAN 1 and a 192.168 VLAN on VLAN 2. VLANs are tagged with a number. Both of those networks could flow over one physical cable between networking equipment, and the VLAN and the switch will make sure that those devices can't talk to one another unless you allow them to, even though they're sharing a physical cable. In the case of managing one of these switches, there's the default management VLAN, VLAN 1, by Cisco sort of convention. If you assign that thing an IP address, you are essentially giving the switch itself an IP address. Think of it like this thing is a computer, and you can give it an IP on the VLAN 1 interface, and then you can configure it so that traffic can flow through any of these ports and talk to the computer. Now this will sort of trip you up. It's as if this thing is internally plugged into a port on its own switch, if that makes sense. But we're not going to do a bunch of VLAN stuff. It's just how you give switches IPs, and we want to assign a unique IP to each of my switches here. And so when I do that, you'll see me do it with the VLAN 1 interface. And then a computer I plug in over here on the same network can actually talk to the IP internal to the switch, and we can manage it. I've assigned all the IPs to the different devices, but you can see they're all very isolated. I can interact with them over the console. Those are plugged in on the back, of course. But the top switch can only talk to the router through its uplink. The bottom switch isn't connected to anything. So let's solve this with some GigaStack modules. We're going to wire this up in what's called a star configuration, meaning every GigaStack module will directly link back to the egg switch. So let's see, I guess I'll put them in the far right. That one, some lights came on. These have light indicators on them, which is kind of nice. That one, and then I guess we'll just do this. These have this terrible habit of coming apart. You gotta finagle them back together. There we go. Let's get that one in there. And then finally, this one. Now there's more sophisticated patterns you could use and failover and redundancy, but I'm not too worried about that, obviously. I don't know the exact speed, but the idea is that these give you a high-speed link, I'm assuming up to close to a gigabit, into the switches, between them, I should say. They're blinking now that they're connected. Let's see if we can get this one. I don't know if this is gonna just auto-magically work. I might have to go configure stuff. So I've got green links there, and I've broken my own rule about crossing over between things, but that's okay. I probably need to take this over here and sort of pin it down or something. That wouldn't look too bad. We'll deal with that later though. Over on the egg switch, you can see we're getting all our console messages about the lines coming up and down. In fact, let's do our logging synchronous trick we learned so that I don't have to deal with that. And let's do a show IP int brief. And I think over here, I think these are our two links right here. So now I'm on egg 1. I should be able, assuming it's working, to ping the middle switch. And I should also be able to ping the bottom switch. And I can. So I have a confession to make. You don't actually need to use the GigaStack modules to accomplish this. I could have just interlinked the switches with, the 1 gig link, or maybe even fast Ethernet, and they can talk to each other in cluster. But the GigaStack modules, aside from having an excellent name, are from a very interesting time when not everyone was doing gigabit Ethernet yet, and it was very expensive until about '03 or '04 maybe. And these GigaStack modules were high-speed links that were cost-effective. So my understanding is that it was relatively affordable to buy these, and so you could interconnect all your clustered switches over 1 gig links, even if you hadn't made the jump to 1 gig link in your data center. So what do we do now? I'm on the egg switch, and I am issued a dir flash command, and I've got this folder here, which hopefully, excuse me, the flash memory is where the system configs and the actual operating system are. So like the binary of iOS that you're running. And I'm taking a look and seeing what I've got. Yeah, this egg switch might already have the CMS software. Let's find out. Let's hit the egg switch in a browser and see if we get anything. Okay, interesting. This is the very basic management. I might need to put a different version of iOS on here. We'll find out. No, it knows it's clustered. See, now it's the Cluster Management Suite. This is great. I'll explain a little bit about the software that's being hosted, but the good news is we don't really have to worry about it. It's just going to work. Come on. I shouldn't have said that. We're stuck here. What if I just close this? No. Maybe we'll have to mess around with Java versions. This is actually kind of cool that these routers host this even just basic interface stuff. So here's the show interfaces command for the egg switch. Now that you're familiar with that, I imagine it's just calling the command line behind the scenes. Maybe they've got some sort of RPC type setup. Let's try this again. Come on. Loading Java applet. Come on. This is not looking good. We're a little jammed up. I'm going to go mess around a little bit. Checking out the Java console, and it's complaining about runtime permissions. It's probably an IE issue because I didn't accept that warning dialog that didn't load. If I restart the browser, I'm so close. I'll have to check what Java version I have. I have to accept whatever this is supposed to be showing me. Think that did it? I don't think so. Oh, it worked. I just pressed enter. Yes, it is party time. We're gonna get GigaStacked. So basically, I think somewhere in here, let's create a cluster maybe? This is the CLAB cluster. Okay, we're gonna create a cluster. Yes, CLAB cluster, egg1. Notice how it says command, and right here it says the command switch. One switch is in charge of the cluster. It's called the command switch. I want that to be this egg switch. By sheer coincidence, or maybe I did it like a year ago when I was messing around with this sort of ad hoc on the bench, I have the CMS software running on this egg switch, so that's great. Here is where it gets interesting. So cluster, add to cluster. Check this out. It recognizes the other switches. So let's go ahead and add power switch 1. We'll just click apply there. You can see it's off doing some stuff, and that happened quite fast. We can click that to see it on the screen. Yes. I'm sorry. I love this. It's just so ridiculous. Now, wasn't it interesting when we went to add to cluster and it already had some candidates? I didn't do anything. Well, let me show you how that works. We're back on the egg switch here. Behind the scenes, these switches are using something called the Cisco Discovery Protocol, or CDP. They're actually reaching out and trying to chat with one another over the network to recognize each other and find one another. Pretty interesting. So we can do show CDP neighbors, and check this out. It has gone off and found these other devices. It knows about HQ Router, which is a totally different series of Cisco equipment, but they all share the Cisco Discovery Protocol, CDP. We already added Power Switch 1 to our cluster, and it already knew about Switch 1 because they're off looking for each other. For example, let's go look at Switch 1. Here we are on Switch 1. Let's do a show CDP neighbors from here. And it knows about egg1 because it's directly connected up to it and they can find one another. It's really cool. This won't come as a surprise, but you can manage the cluster on the CLI. So I'm back on egg and I can do show cluster, and check this out. It knows it's the command switch for the CLAB cluster. It's got 2 members, I think one of which is itself. Now back to the CDP stuff. We're gonna do show CDP neighbors detail, and it's gonna give us a little more information. Switch 1 is the one we're gonna add to the cluster. It's not in there yet, and it's on interface gigabit 010. So we're gonna run this command. We need the MAC address to programmatically over the CLI add it to the cluster. We don't actually have to use the UI. So we're going to run show MAC address table for that interface. And we're going to get back a couple MAC addresses. I believe we want this first one. Back in global configuration mode, we're going to say cluster member. Let me refresh my memory here. I did a little reading, but I haven't tried this before. We need to assign it a unique member ID. I think we already have 0 and 1, the egg switch and the power switch. So we're going to give it cluster member 2 MAC address, and then we're going to paste that in. And that was awfully fast. Let's do another show cluster. And look at that. It says total number of members 3 now. Back over in the UI, let's refresh and see what we get. Come on. Interesting. So it refreshes into this topology view. Good news is we do have 2 switches. What's this one? Looks like we can look at host name. That's the one we just added. So it worked. How do I get back? Front panel, I think is what we want. Okay. Bam. Yes. All right, we are GigaStacked, and we can come in here and configure these things. Now, I mean, again, it's not a true stack. They're not sharing resources. It's just a convenient spot to see your fleet of switches, and you can configure each of these things independently, even down to the port settings. I can disable it. I can put it in shutdown, all sorts of stuff. And I just think it's awesome. This is so cool to have the retro rack all stacked up like this with the Cluster Management Suite. I did want to talk just a little bit how you can tell if these things are even going to be capable of hosting the Cluster Management Suite. So here I am on that middle switch, power switch 1, and we're going to issue a dir flash. This is where the iOS version and any files the thing has are kept. And you'll notice I have an iOS version. This is the iOS naming convention, which I have to look up every time. I can never remember what any of this means, but you can see it's a .bin. That is just the iOS image, the one I'm interacting with. However, if we go back over to the egg switch and we do a dir flash, it's a little different. It's got this thing that looks a lot like the iOS version, but it is a folder. That's what that D right there means. So let's copy this and take a look at what's in there. We're going to do another dir flash. We'll paste that in. Maybe. There we go. I pasted it twice. We're looking in that folder, and it also has a bin. So here's the iOS version it's running, but there's this HTML folder. And this is how you can tell that a piece of equipment is probably hosting something with a GUI. And then we can actually look inside that HTML folder, and we see all sorts of stuff related to CMS. Here's cmsboot.jar. That's probably that Java applet that's loading. So you might not always want to run, a GUI or cluster management software on all your switches. It's totally optional. And so Cisco would ship like a tarball version of the supported iOS versions, and that would contain the HTML folder. In another video about a year ago, I actually dealt with downloading those and getting them on the switches. We got lucky today that I already had it on the switch I wanted it on. If you're interested in seeing more detail on that, I'll link to that video down in the description. Back over here, this is looking really good. I even tidied up the GigaStack cables, got them pinned over there, which is very unlike me, but I'm really digging how this is coming together. This is going into the router. We'll deal with that shortly, make that look a little better. There's sort of an interesting side effect of all this work we did, which is I now have gigabit speeds in the retro rack. I was just doing fast Ethernet here. Over in my modern server, I'm running Proxmox, which has a ton of VMs in it, and that I'm actually able to network them over to the retro rack. And they're coming in through this cable right here, which is normally one of these fast Ethernet cables headed on the back. I think what I want to do is get this on a gigabit connection, so I have gigabit speeds between this rack and my other one, all my VMs. And of course, one way I could do that is a GBIC up here, or I could simply plug it in right here, and I would be done. But I'm trying to avoid all this wire crossing going on. So I think I'm actually going to sacrifice one of these ports. I think, yeah, that one. So I'm going to take this out, and you won't really notice. And then I'm going to slap a 1 gig RJ45 GBIC in there. I don't know if this one works. They usually give me trouble. But now, just so that it looks a little tidier, or maybe, oh, that might have been the wrong port to choose for that. That's a little stressed. We need to do maybe like, I should have tested this first. Maybe port 20. Let's do that. Yeah, that's a little better. So now what I'm going to do, I'll bring this one around the back, and I'll have a 1 gig link up to the other rack right here. and it's not going to look too stupid, I don't think. Let's get port 22 wired back up. Yeah, I think that is going to look pretty slick. I'm going to hook this up, and let's do a quick speed test somehow, and see what kind of speeds we're getting through this egg switch and everything. Got everything hooked up, and I'm seeing no activity. I think this GBIC module has given me problems in the past. Let's go see if I have another one. Let's try this one. This is the only other one I could find, so this plan is rapidly deteriorating. I'm seeing nothing. Maybe I got to keep looking around, see if I got another one of these things. The other option, of course, is just one of these maneuvers. Yeah, see that light's turning on, so my link is fine. I could do that. That's okay. Really like to get one of these working. Maybe I need to go mess in the CLI. Yeah, I can't find another one, so we're going to do it the somewhat janky way, like this, which is unfortunate. I don't think I've ever been able to get these to work. I have two of them, and I've never had any luck, so they must just be busted. I'll have to hunt down some more. Well, now this is connecting the other rack with a bunch of VMs over 1 gig, but I need another computer over here to do a reasonable speed test, and all of my RJ45, 1 gig GBICs, maybe they just don't work in that one. Guess I didn't think about that. That's interesting. Works just fine in the egg switch, so my modules are okay, and either this GBIC port is bad, or more likely, this switch doesn't support this module. Interesting. Yeah, I think it's because it's an older switch. This is the XL, and these are 3550s. It works on, my other one works down here just fine. So what we're going to do is plug our Raspberry Pi as our other computer, just like that. And then we're going to run a speed test from the Pi on this switch. It's going to have to flow into the egg switch and out to the rack. And that means we're actually going to flow over these GigaStack cables. We'll see what kind of speeds we can get. Check out this primo setup with the power coming in. He's booting up, plugged in. Oh, I just saw the light come on. All right, let's do a speed test. Here I am SSH'd into that dangling Raspberry Pi. I'm going to set up an iPerf server. iPerf is a latency testing tool for networks, and I'm going to put it in server mode. So it's just going to sit here and wait. I was able to find its IP because it was handed out by the router, the VXR, and you can do a show IP DHCP binding in this old version of iOS anyway. And I figured out it was assigned 10.00.105. That's the Raspberry Pi. This is Proxmox running on the modern rack, and it's hosting a bunch of VMs. We're going to SSH into one of these VMs. I use them for various things, and we will set it up as an iPerf client. The two will connect over our GigaStack infrastructure, and we'll see what kind of speeds we can get. Here I am SSH'd into a VM on the modern rack. I'm going to connect with it as a client to the Raspberry Pi, and hopefully we get some speed tests, and we're getting 200 megabits a second. Not too bad, not too bad. I don't know how many it does, 10 probably. 200 megabits a second. That's actually not too bad, but we're being bottlenecked by something. So gigabit should be quite a bit faster than that, but obviously it's not fast Ethernet. Fast Ethernet would have been 100 megabits per second, so we're getting something around 25 megabytes per second, and it's probably the Raspberry Pi. I think it can only even do a theoretical 300 megabits per second, even though it theoretically has a gigabit Ethernet port. Good enough for me though. We're obviously surpassing fast Ethernet, so that's pretty cool. We have one last thing to take care of, and it's this dangling uplink from the egg switch to this router here. On the back of the router, there's actually 3 GBIC RJ45 combo ports. You can only use one of those at a time, so it's either RJ45 or GBIC. Right now, you can see it's RJ45, and that's obviously flowing in right here. We're going to replace that with a fiber uplink over GBIC. Getting pretty serious down here. I've got approximately like 300 of these fiber GBICs, so that shouldn't be a problem. I should be able to find 2 that work. So right here, we're going to get one of these fiber modules installed, and of course we'll get a little 3-foot fiber patch cable going. We'll take that around and of course hook it up on the back, but first I'm going to bring the port down, and I have to switch the mode between GBIC and RJ45. If you plug in the GBIC while it's in RJ45 mode, it brings down the entire network and the router locks up and you have to restart it. I've inadvertently done that twice in the past. I need to actually sit down and recreate it. Let me know if you've seen something like that before. Today's not the day to experiment with that. So let's go switch the mode on that port. I'll unplug this, and then we'll get the fiber plugged in. Back on the HQ router, we're concerning ourselves with this gigabit Ethernet interface 01. So let's get in there and have a look at that guy. Now, there's a media type command. And so you need to switch the thing between GBIC and RJ45, in my experience. We're going to switch it over to GBIC, and I think that is probably okay. It's complaining about speed and duplex settings. We'll see how it does. Let's go plug in the fiber cable. Just plugged it in, and it was negotiating, and the light was orange for a while, and now it's green. So I think we've got the 1 gig uplink over fiber, which is pretty industrial in my opinion, pretty enterprisey, into the egg switch. I haven't checked the computer yet, but there is the final look of the GigaStack aggregation switch setup. For the retro rack, we've got fiber going into VXR. We're GigaStacked over here. We're tidy. We've got a 1 gig uplink to the other rack. Man, that was a lot of progress on the retro rack today. Well, let's go do some pings to make sure this thing is actually talking to everything else. And I think that's it. Let's just do a quick ping of something else in the rack to make sure everything's okay. Uh-oh. Never mind. We're cool. Everything's cool. All right. 1 gig fiber uplink to the GigaStack. We introduced fiber into the rack. We're thoroughly GigaStacked. Huge progress for the basic infrastructure for the retro rack today. And I've actually got like 5 more of these Cisco switches that theoretically can participate in that GigaStack cluster. So I'm going to have to try really hard to refrain from doing that because I've got way more port capacity in there than I'm ever going to need for the foreseeable future. Just wanted to throw it out there that I'm going to be attending VCF Southwest at the end of next month. I'll likely be there on Saturday. I think it's June 21st. So if you see me, definitely say hi. Hope you enjoyed following along. I love that GigaStack module stuff, the cluster management UI. It's super fascinating and it's just fun to look at, and I'm absolutely thrilled that it's actively running all the time now. Well, that rack doesn't, I was going to say all the time. That rack is not on all the time, in case you're curious. I flip it on whenever I want to play with it. It's only on for hours at a time. But I'm thoroughly happy that I can flip all that on and have the cluster management suite running. Super awesome. Thanks again for watching. If you'd really like to support the channel, please consider subscribing if you haven't already. And I've also got a Patreon. I occasionally post an early video, behind the scenes, what I'm thinking about, and that sort of thing. Thanks once again. I'll see you in the next video.